Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on quantum physics from October-November 2021 paper 4 variant 2. In this question, we will discuss what is meant by photoelectric effect, how we can define work function energy, and what is threshold frequency. Then we will talk about particle model of light, and at the end of this lesson, we will also do some calculations to calculate work function energy of calcium. For question number 9, part A, we need to state what is meant by photoelectric effect. Photo simply means light. So let me write down here. Photo simply means light. Photo is light. And electric, simply you can understand, is electricity. So photoelectric effect simply means that we can use light and we can convert light into electricity. And this phenomenon is called photoelectric effect. So simply we can say emission of electrons, photoelectrons. In this case, you can see light is coming. So light, or better way to say this one is electromagnetic radiations. So when electromagnetic radiations fall on metal surface, electrons are emitted. We call them photoelectrons because these electrons are emitted due to light. So we call them photoelectrons. And this phenomenon is called photoelectric effect. So photoelectric effect simply means that emission electricity. We can say electricity is emission of electrons. So we can write down emission of electrons from metal surface, or simply you can say from metal. Emission of electrons from metal due to light means EM radiation, electromagnetic radiations. So photoelectric effect simply means that emission of electrons from matter due to electromagnetic radiations. That is called photoelectric effect. Now let's try to understand how we can write down a proper answer. This question has 2 marks, so we have to mention 2 points. This is how you can write down a proper answer for this question. So simply in this case, you can say emission of electrons from a metal, or you can say from a metal surface. If you write down this one, you will get 1 mark. And the second point, you can say when electromagnetic radiation is incident on electrons. So simply you can say emission of electron from metal surface when electromagnetic radiations are incident on matter. If you write down these 2 points, you will get 2 marks. For the second part, we need to state what is meant by work function energy. This is depending on emission of electrons, means when electrons, photoelectrons are emitted and when photoelectrons are not emitted. This is condition for emission of photoelectrons. So let's try to understand photoelectrons when they are emitted, when they are not emitted. Photoelectrons. Photoelectrons are emitted, may emitted, will not be emitted. So I will simply say will not be emitted. So simply we can say not emitted. Emitted, we will say possible they will be emitted. Possible. And in this case, this is impossible. Possible is very important. Here is not possible. Electrons will be emitted, mean it is possible that electrons will be emitted if energy of coming photon, means energy of coming photon, if energy of coming photon is greater than work function of the metal. So we can say energy of incident photon, if this is greater than or equal to work function of the matter, then it is possible that electron will be emitted. So in this case, this is possible. If energy of coming photon is less than work function of the metal, electrons will not be emitted. Mean photoelectrons will not be emitted. So work function energy, simply we can say, is the minimum energy required for an electron to leave metal surface. If the energy of the photon is less than that minimum energy required for emission of photoelectron, electron will not be emitted. If greater than or equal, there is possibility that photoelectron will be emitted. That's all what we need to say about work function energy. Now let me show you a proper answer for this question. This is how you can write down a proper answer. In this case, you have to mention minimum energy. So this is condition. So you have to say minimum energy. Minimum energy required for an electron to leave metal surface. Metal surface is also very important because we are saying minimum energy, so electron has to be emitted from the surface and just sitting here, and its kinetic energy is equal to 0. So then we can say energy of the photon is equal to work function energy. If you write down this, you will get 1 mark. Now let's try to understand photoelectric effect and work function energy with the help of this animation. In this case, you can see here electromagnetic radiation we are using in this case is UV. So this is ultraviolet, and the metal, this metal, you can see this metal is sodium. This metal is sodium. So this is sodium metal. Simply we can write down this one is sodium and a sodium metal. In this case, you can see if UV light, there is emission. Means UV light can cause emission of photoelectrons from sodium. So we can also say in this case the energy of the photon, energy of UV photon is greater than work function of sodium metal. So that's the reason there is emission of electron. And this emission of electron from the metal surface due to electromagnetic radiation is called photoelectric effect. Now if we change the frequency of this light, we move to indigo, you can see still electrons are emitted. It means that indigo, energy of indigo photons is also greater than work function of sodium. But if we go to blue light, again you can see electrons are emitted. Let's try to find out which color of light will not cause emission of photoelectrons from sodium. If we decrease this frequency, mean if we move to green light, in this case you can see still photoelectrons are emitted from sodium metal. If I increase intensity of green light, you will see more photons are coming. Higher intensity simply means that higher number of photons. Let's try to understand a little bit about intensity. Intensity simply equal to power over area. But power we can say this is energy over time times A. This is energy of electromagnetic radiation, but we can break down this one into energy of single photon times number of photon divided by TA. And energy of photon we can also write down is equal to HF divided by TA. Very important point, intensity and number of photons. Now let's try to understand about intensity and frequency. Now in this case, if I keep this intensity same, for example, if I keep this intensity same and I increase frequency of light, frequency of electromagnetic radiation, you will see number of photons will decrease. It simply means that if we keep intensity same and we increase the frequency, so the number of photons have to decrease, and vice versa is also true. Now in this case, if we keep intensity same but we decrease frequency, so the number of photons have to increase. So this is what you can see here. So if we keep intensity same and we decrease frequency, so the number of photons will increase. Very important point, they will ask you in different past papers. You need to understand how intensity change with frequency and number of photons. Now let's try to find out at which color of light no electrons will be emitted from sodium. Let's move on to yellow light. If you go to yellow light, you can see here now no electrons are emitted. It doesn't matter what is intensity of light. If I make this 100%, you see a lot of photons of light are coming, but no photoelectron is emitted. It simply means that energy of yellow photon, so simply we can say energy of yellow photon is less than work function of sodium metal. Or simply we can say the frequency of yellow light is less than threshold frequency. So these points are very important points. We have to be very clear about these points. Now let's try to change this metal. If we change this metal, let's move on to zinc, for example. For zinc, as zinc is a different metal, different metals, they have different work function and they also have different threshold frequency. So simply we can write down different metals, they have different work function. So we can write down different metals, they have different work function, and different metals, they also have different threshold frequency. We will see this one with the help of this animation very soon. Now in this case we have zinc metal. You see when light is yellow, no photoelectrons are emitted from zinc. So we can replace this now. This is zinc metal now. Zinc. So it has different work functions. So this is zinc. Now if we increase the frequency of light, you see at green again no photoelectrons are emitted. It means the work function of this metal is greater than energy of photon of green light. Now if we move to blue light, again you can see no photoelectrons are emitted. It simply means that the work function of zinc is still greater than energy of blue photons. If we go to indigo or purple light, simply we can say still you can see no electrons are emitted from zinc metal. It simply means that work function of zinc is still greater than energy of individual photon, or we can say the threshold frequency is greater than frequency of electromagnetic radiation. In this case our light is purple light, or you can say indigo. But if we go to UV, still you see photoelectrons are not emitted. But if we increase this frequency more, you see at this wavelength photoelectrons are emitted. Means at lower wavelength and higher frequency photoelectrons are emitted. So simply we can say energy of UV, we can say energy of UV photons is greater than work function of zinc, or we can say frequency of UV light is greater than threshold frequency for zinc. So that's all what we need to understand about photoelectric effect, work function, and also threshold frequency. I hope these points are very clear to you. Let's go to question back and try to answer remaining questions. For part B, it is given to us a polished calcium plate in a vacuum is investigated by illuminating the surface with light. It is found that no photoelectric current is produced when the frequency of the light is less than 6.93 times 10 to 14 Hertz. State the name of the frequency below which no photoelectric current is produced. And that minimum frequency is called threshold frequency. So simply we need to write down threshold frequency. If you write down threshold frequency, you will get 1 mark, and this is B mark, mean it has to be in the answer. Now if we move to second part, for the second part we need to explain how the photon model of electromagnetic radiation accounts for this phenomenon. Phenomenon means photoelectric effect. First thing we need to understand, photons are discrete packets of energy. Each photon has fixed amount of energy. So simply we can say, first of all, photons are discrete packets of energy, means they have fixed amount of energy. Discrete packets of energy. Discrete packets of energy. So this is one point we can write down. Discrete packets of energy. And the second point we can say energy of photon. Energy of each photon is equal to h times f. And this is frequency of electromagnetic radiation. So energy of photon depends on frequency of electromagnetic radiation. This can be over second point. We have to write down at least 3 points. The third point we can say interaction between one photon only interact with one electron. So the interaction between photon and electron is 1-to-1. So one photon only interact with one electron, mean it gives all of its energy to only one electron. So this point is also very important. So if you write down these 3 points, you will get 3 marks. Now let me show you how you can write down your answer. This is how you can write down your answer. Your answer, as we have discussed, point 1, you can say photons are discrete packets of energy, mean each photon of each radiation has a fixed amount of energy. Energy of photon depends on frequency of electromagnetic radiation, as we have discussed second point here. And the third point, you can say electrons can only absorb a single photon of energy, means one electron can only absorb one photon. So the interaction between electron and photon is 1-to-1. So these 3 points you have to write down. If you write down these 3 points, you will get 3 marks. For the last part, question is asking us to calculate the work function energy in electron volts of calcium. But threshold frequency means the minimum frequency is already given to us in part B. Threshold frequency given to us is 6.93 times 10 to 14 hertz. So this is the minimum frequency. If the frequency of electromagnetic radiations is less than this, no photoelectron will be emitted. And this frequency we call is threshold frequency. For this question, we need to calculate work function energy, and work function energy is simply equal to HF naught. F naught is the threshold frequency. So this is threshold frequency. If threshold frequency is given to us, simply we can use this formula and we can calculate work function energy for any metal. This is threshold frequency. Now simply we need to plug in these values. H is a constant. This is Planck constant. And value of this one is 6.63 times 10 to negative 34. We can plug in this value. We can sub in value of threshold frequency, that is 6.93 times 10 to 14 hertz. If we solve this one, we will get our answer in joules. That will be equal to 4.59 times 10 to negative 19 joules. Our answer has to be in electron volts. Now simply we need to convert this one into electron volts. 1 electron volt is equal to 1.6 times 10 to negative 19 joules. 10 to negative 19 joules. Now if we simply divide this one by 1.6 times 10 to negative 19, means this is joules over electron volt. Joules over electron volt. So our final answer in this case will be equal to 2.87 electron volts. So this is our final answer. This question has 2 marks. The first mark you will get if you have plugged in these values. Means if you have done this step. If you have done this step, you will get 1 mark. C1 mark you will get. And the second mark is answer mark. If you have got the right answer, you will get second mark.